Hello everyone, I am Karthik, Assistant Professor of Mathematics, SNS College of Engineering. In this lecture video, I will explain about what is directional derivative and its definitions, examples, and finally some applications. First, we have to know that what is directional derivative. The directional derivative is a concept in calculus that measures the rate at which a function changes along a specific direction in its domain. Imagine you are standing on a mountain and you want to know which direction the slope is steepest. The directional derivative helps you find this by measuring how fast the function representing the height of the mountain changes as you move in the specific direction. Definition of directional derivative. The directional derivative of a function f of several variables at a point x0, y0, etc. z0 in the direction of a unit vector v equal to a, b, etc. c is the rate of change of the function f at that point in the direction of v. Mathematically, it is denoted by d dot f and is given by the dot product of the gradient of f at x0, y0, z0. Formula for calculating directional derivative. The formula for calculating the directional derivative of a function is del dot f, where del dot f is the gradient of f evaluating at a point x, x1, x2, etc. xn. Then the gradient is a vector of a partial derivatives of f with respect to each variable. Geometric interpretation of directional derivative. The geometric interpretation of the directional derivative involves visualizing how a function changes in specific direction. Imagine you have a surface representing a function f of x, y in 2 dimensions or f of x, y, z in 3 dimensions. At specific point x0, y0 in 2D or x0, y0, z0 in the 3D. Gradient direction. The gradient of the function at a point gives you the direction of the steepest ascent. Directional vector. Now imagine you have another vector, say v, representing the direction you are interested in. This vector could be any direction in the plane or space. Third one is projection. The directional derivative is the projection of the gradient vector onto the direction vector v. In other words, it tells you how much of the change in the function is happening along the chosen direction. Finding the directional derivative in a given direction. Here del is the operator. Del equal to dou by dou x I vector plus dou by dou y j vector plus dou by dou z k vector. We know that gradient del dot v equal to dou by dou x vi vector, dou by dou y vj vector plus dou by dou z of vk. Divergence del dot a equal to differentiation of f1x with respect to x plus differentiation of f1y with respect to y plus differentiation of f1z with respect to z. Relationship between gradient and the directional derivative. Definition of the gradient. The gradient of a scalar function is del dot f and it is written as del f equal to dou f by dou x1, dou f by dou x2, etc. dou f by dou xn. The directional derivative of f at a point del dot f equal to del dot f x1 naught, x2 naught, etc. xn naught into v. Relationship. The directional derivative measures the rate of change of the function f in a specific direction. Gradient direction. The gradient of f at a point indicates the direction of steepest ascent of the function at that point. Next, applications of directional derivative in real life sceneries. First, agricultural slope monitoring. First one, directional derivatives can be used to assess the rate of change of soil elevation along different directions on agricultural slopes. Second one, crop yield prediction. Directional derivatives can also be applied to analyze the rate of change of crop yield across different regions of a field. Wind energy optimization. First one, directional derivatives can aid in determining the optimal placement of wind turbines. Then directional derivatives can also be used to assign the layout of wind farms to minimize interference between turbines and maximize energy output. Hydrological analysis. First one, river flow modeling. Directional derivatives can help in modeling the flow of water in river systems. Watershed management. Directional derivatives can be applied to analyze the rate of change of water flow across different regions of a watershed. Thank you.